Imagine you are riding a bicycle up a hill. You feel yourself working harder as you climb. Where does all those efforts go? Get stored as energy. Imagine a person pushing a car along the road. The person is actually doing work on the car. Why? Because work is done when a force moves an object a distance in the direction of the force. So the man pushing this car is said to possess energy, which he exercises by making the car move some distance. Football players running around the field have energy because they are capable of moving their weight some distance. Mango fruits falling from the top of a tree all possess energy. So today we'll explore the concept of energy in physics. That is what energy is. We'll also see the various forms of energy, how to calculate energy, and the principle or the law of conservation of energy. But before then, let's briefly recap the concept of work. Previous video established the fact that work is said to be done when a force moves an object a distance in the direction of the force. Our focus on today's video will be on the concept of energy. Energy is the ability or capacity to do work or cause a change. Work and energy are measured in the same unit, that is the joules, meaning that the SI unit of energy is the joules or the kilojoules, depending on the concept. There are many forms of energy, that is, energy comes in various forms. We have heat, also referred to as thermal energy, light or the radiant energy. We have electrical energy, chemical energy, nuclear energy, and mechanical energy, to mention but few. However, in this tutorial video, we shall be concerned with considering only mechanical energy. Furthermore, mechanical energy is classified into two types. First one is potential energy, also called stored energy. Second one is kinetic energy, also called the motion energy. Potential energy is the type of energy possessed by a body as a result of its configuration. That is the ability of a body to do work by virtue of its position or state. For example, coconut fruit possess stored or potential energy which will be used to do work, in this case fall to the ground. Potential energy is further divided into two types. First one is elastic potential energy. It's a type of energy possessed by an elastic body. For example, spring has ability to do work, that is stretch or compress when stressed, that is when force is applied. The second type of potential energy is the one referred to as gravitational potential energy. Gravitational potential energy is the ability of a body to do work due to its position or height above the ground level. Because gravity is the ultimate source of energy for a body or particle above the ground level, it is correctly called gravitational potential energy, with an acronym GPE or EGP, where E means energy, G means gravity, while P means potential, or the PE, where P stands for potential and E energy. Formula for gravitational potential energy is mgh, where m is the mass of the body, g is acceleration due to gravity, which is the ultimate source of energy, with 9.8 or 10 meters per second square. H is the height of the body above the ground level or the reference point. So to calculate gravitational potential energy, also called potential energy, we look at for the mass of the body, its height above the reference level. Therefore, potential energy depends on mass, its height, and the acceleration due to gravity. Now let's exercise our hands on activities, that is problem questions that involves calculation of gravitational potential energy. Find the potential energy of a boy of mass 10 kg standing on a building floor 10 meters above the ground level. Now let's list out the given parameters. We have the mass, we also have the height of the building, that is h, 10 meters, and of course our g being acceleration due to gravity. With this the value is 9.8 meters per second square. Now let's substitute all these values into our formula. Equal to mass, our mass value is 10, times g, our g value is 9.8, times h, our h value is 10. Therefore, 10 multiplied by 9.8 multiplied by 10 gives 980 joules. Remember, we did say energy and work have similar units, that is joules. Therefore, the potential energy of the boy is 980 joules. Now, let's look at the second challenge. A 3000 grams object is 10 meters above the ground. What is its potential energy? Mass of the object is given, that is 3000 grams, but the SI unit of mass is in kilograms. So, firstly, we'll convert 3000 grams to kilograms by simply dividing by 1000. So after dividing 3000 by 1000, the mass of the body changes to 3 kg. We're also given the height of the object, that is 10 meters, and of course our acceleration due to gravity is 9.8 meters per second square. Now we'll calculate our potential energy by substituting all these values into our formula. So potential energy equal to mass of the object will have 3 kg multiplied by acceleration due to gravity, that is 9.8, multiplied by the height of the object, that is 10. 3 times 9.8 times 10 gives 294 joules. So the potential energy of the object is 294 joules. If you are getting value from this video and yet to subscribe to my channel, please kindly hit the subscribe button and turn on the notification bell. Thank you. I haven't talked about potential energy, which is one of the types of mechanical energy. Now let's proceed to talking about second type of mechanical energy, which is kinetic energy. Kinetic energy is the ability of a body or a particle to do work as a result of its motion. That is, kinetic energy of an object is related to its motion. We could see coconut fruits in our coconut trees. These coconuts possess potential energy, but now that the fruits are free falling, that is, now that they are descending, the potential energy is transformed or converted to kinetic energy because of movement or motion. This is in agreement with the principle of energy conservation. Another way to define the kinetic energy of a body is half of its mass times velocity squared, or 1/2 the product of mass of the body and the square of its speed. This means that kinetic energy Ke only depends on the mass and velocity of the body. Please note, the massive the object and the faster it is moving, the more the kinetic energy it possesses. Also note that kinetic energy cannot be negative, and it only tells about speed of an object. Examples of kinetic energy are footballers playing in the field, and objects falling freely under gravity, a car in motion, a cup falling freely from a table, and lots more. An object with mass 5 kg is moving at constant velocity of 15 meters per second. Calculate its kinetic energy. This is the formula for calculating kinetic energy. Ke 1/2 times mass of the body being 5 times square of the velocity given. So 1/2 times 5 times 15 square gives 562.5 joules. Therefore, the kinetic energy is 562.5 joules. Now let's look at the second challenge. A 2 kg ball is rolling at 5 meters per second. What is its kinetic energy? The given mass is 2 kg, while the velocity of the speed is 5 meters per second. This is the formula for calculating kinetic energy. 1/2 times the mass 2 times square of the velocity. So 1/2 times 2 times square of 5 gives 25. So the kinetic energy of the ball is 25 joules. Now let's look at the principle of conservation of energy. This law states that in a closed or isolated system, the total amount of energy possessed by an object or particle remains constant as the body moves, although the energy may be changed from one form to another. Another way to state this is that energy can neither be created nor destroyed in a closed system, but it can be changed or converted from one form to another. In mechanical energy, this law states that the total amount of energy is the sum of kinetic and potential energy, which is always constant, but the energy may change from potential to kinetic or from kinetic to potential. That is, the total amount of energy is equal to potential energy plus kinetic energy is constant. Let's look at the examples of the principles of conservation of energy. The first example is that when coconut fruit falls, potential energy converts to kinetic energy. The second example is when a car in motion stops, kinetic energy is converted to potential energy. A stunt rider is trying to leap across a valley as shown above. At the starting point A, his initial speed v is 45 meters per second. With what speed will he strike the ground at point B? We'll use the principle of conservation of energy to answer this question. That is, the total energy at point A is equal to the total energy at point B. Firstly, let's write the energy equation. At point A, that is the initial point, the kinetic energy at point A is 1 over 2 mv square A, while the potential energy at point A is mgha. At point B, that is the final point, kinetic energy at the final point is 1 over 2 mv square B, while the potential energy at point B is mghb. Since there are no energy losses, we equate the energies. The kinetic energy at point A plus the potential energy at point B is equal to the kinetic energy at point B plus the potential energy at point B. We cancel out m since mass is constant throughout. By the time we do that, we will be left with x. Now let's plug in these values and solve for VB. VA square, our VA value is 45. Then square G, we already know what G is. G means acceleration due to gravity. Value is times the height at point A, we have 80, equal to the velocity at point B, which is unknown, plus G, we did say the value of G is 9.8, times the height at point B. So we have 1 over 2. The square of 45 gives 2025 plus 9.8 times 80 gives 784 equal 1 over 2 v square B plus 9.8 times 30 gives 294. 1 over 2 times 2 gives 1012.5 plus 784. When positive 294 crosses the equal sign, becomes negative 294 equal 1 over 2 v square B. 1012.5 plus 784 minus 294 gives 1502.5. When we multiply this by 2, it gives 3005 equal v square B. To get the velocity at point B, we will take the square root of these values. So the stunt rider will strike the ground with a speed of approximately 54.83 meters per second. I hope this video helps. Please, if you really got value from this video, give this video a thumbs up. And if you have any questions or topics you would want us to cover in future video, please kindly drop that in the comment section. And if you are yet to subscribe to my channel, kindly hit the subscribe button and turn on the notification bell. Please stay tuned for the next video where we discuss the concept of power. Thanks so much for watching. See you in our next video. Bye.